Okay, a frequency is a count of how many observations fall into a category. A frequency distribution is a listing of all categories along with their frequencies. Frequency distributions can be used with both qualitative and quantitative data. The definitions below are used in discussing and constructing frequency distributions for quantitative data. So you have relative frequency, that is the proportion or percentage of the count in a category relative to the total number of terms in that in all the categories. So this is all stuff that you know the concept, it's applying different names to it, if that makes sense. Okay, this is how they're named in statistics. A relative frequency distribution, listing of all categories along with their relative frequencies. In order for it to be a relative frequency distribution, the sum of all the frequencies must be 1. Now, when you are adding them up, because of rounding, sometimes you're going to get 0.999 or 1.01. That is okay because that's a rounding thing. So just know that if you wind up, if you're adding them up and you get 0.99 or 1.001, that's the same thing as 1. Okay? It's okay. It's not a big deal, guys. Cumulative frequency distribution, okay? That is the sum, the sum of the frequencies for that class and all of the previous classes. So example 1. 40 people were asked what beverage they drink for breakfast. Construct a frequency distribution for the data. Summarize the results. So our classes are, and by the way, I left off one, so you're going to have to put it underneath. We have water, we have milk, coffee, juice, and tea. Just put tea underneath the table. Okay? All right, so I want you to go count them up, use tally marks if you need to, however it is that you need to figure out how many are frequency, what the frequency is. So how many are in each category. So your frequencies are 14, 8, 9, 6, and 3. That's how many times it occurs. Your relative frequency is the percentage or the proportion. So my total, 40 people. Always check and make sure when you do frequencies, add it up and make sure you got everyone. I've caught myself on mistakes a few times doing that. Make sure it has the right total. And then you take the numbers and you divide by the total. You can either leave it as a simplified fraction or you can change it to a percentage. I do not care unless it specifically says in the directions what to do. Okay, so my answer for this one would either be 7 over 20 or 0.35. Now, when we start graphing the percentage, the decimal may be more useful than the fraction. So the next one is going to be 1/5 or 0.20. 9 over 40 or 0.225. Because these are all nice fraction or decimals, I'm going to go ahead and use all the decimal places. Otherwise, you're going to typically round to because it's using it as a percentage, okay? 3 over 20 is going to be 0.15. Sorry, 6 over 20. Don't know where I got 3 from. I know where I got 3 from. 3 over 10. No. 6 over 40, 3 over 20. Miss G's crazy today, guys. That's what happened. This is 3 over 40, which is 0.075. Okay, to create a frequency distribution table, there should be between 5 and 20 classes. Not a rule, but a general guideline. Generally speaking, you're going to have fewer. It sort of is dependent upon how many data points you have. If you have 500 data points, it's okay to have 20 classes. But if you only have 40 data points, 20 classes doesn't make sense. So you kind of have to use common sense, okay? There's going to be a lot of times I'm going to tell you, use this many classes, so it's not a guesswork for you. It is preferable, but not necessary, that the class width is an odd number because it makes graphing a little easier. The classes cannot overlap, so you can't have like from 0 to 8 and then from 8 to 16, okay? It would have to be 0 to 8, 9 to 16. So you cannot have any overlapping. They have to be what we call mutually exclusive. The classes have to be continuous, so you don't skip it. If it's 0, that just means it's not going to have whatever on the graph, or it's going to be labeled as 0. It must be exhaustive, so you can't have any data that's missing. And the classes must be equal in width. So the exception, which doesn't happen most often, but sometimes, depending on what we're looking at, like we'll say less than 40, so that would be anything up to that point, or 100 and up. A lot of times when we're talking ages, like we'll do age groupings, and then you get to like a certain age and like 55 and up or 60 and up or whatever. So that's going to be the only time that your class width wouldn't be the same, but those don't happen like all that often. Usually it's going to be pretty clear cut. At least what I'm asking you to create. I may be asking you to look at data that's going to be that, but I'm not going to probably ask you to create that data, okay?
So the width is pretty much the range
of each one, of each class. Okay, or if it's quantitative. If it's qualitative, it's pretty clear cut. So steps to create a frequency distribution. You have to determine your classes, so you're going to find your highest and lowest values. Find the range, select the number of classes desired, find the width, and I know this is a lot of steps. Generally speaking, what I've done on the quiz is I've done step by step. Hey, find this for the first problem, and then the next time I don't tell you the steps, and you just are supposed to be able to infer what they are because I gave them to you, okay? Because this is not like one of these super, super important things that you have to know how to do, but you do have to know how to do it. So I will kind of guide you on the quiz on what the step is as long as you know what to do, okay? So that is there, though, for you to go refer to whenever you're working on homework. So, example 2. These data represents the record high temperatures in degrees Fahrenheit for each of the 50 states. Construct a grouped frequency distribution for the data using 7 classes. So I'm telling you how many groups it is. So highest value out of that is 134. What is the lowest value? 100. So my range, remember range is high minus low. Range is 34. And if I have 7 classes, I take the range, divide by the number of classes. So I get, it's like 4.9 something, so we're going to round up to 5. Is everyone okay with that? Okay. So we're going to figure out our class limits, and then we'll talk about the boundaries. So first, the class limits, starting at 100, will be 100 to 104, not 105, because that's 100, 101, 102, 103, 104. That's 5 things in that class limit. So don't just add 5, especially when you're starting at something with a 0. Think through that one. The next one, 105 to 109. This one gets kind of easy because at this point you're adding 5 to the first number, adding 5 to the second number for the rest of them. Okay, so fill in the rest of your class limits. So thankfully, everything fits in that. If for some reason you notice, like you get to the end and you're like, okay, I did something wrong because I can't get my highest value in there, you need to go adjust your width. So I would have to go change it and basically change the first one to be 1 more and then redo all of them. Okay. Class boundaries. So this is one of the things y'all were asking me that was in the chapter 1 stuff, but we weren't doing until chapter 2. When you're doing your class boundaries, because these are whole numbers, we're going to go one decimal place after it. So we're going to go to 0.5. And you are going to subtract 0.5 from here and add 0.5 to this. So my class boundaries are 99.5 to 104.5. The reason we do this is so that it's continuous. So the next one's going to be 104.5 to 109.5. So there are no gaps in my data. That's the reason why we do this.
It'll always tell you how much to subtract and add, or do you just have to?
This is always going to, so I'm going to explain that in a minute. Basically, you're always going to, since this is a whole number, I went one decimal over and it's going to be 0.5. If it had been like 100.3, I'd go 0.05 and then I'd do plus or minus 0.05. So always go one decimal place more and then you're doing halfway basically. So it's always going to be a 5 that you're adding or subtracting. Did that answer your question?
So just if it has a decimal, do 0.05, and if it's a whole number, do 0.5.
Yeah, so what you go one more decimal place beyond what the data has.
Okay.
Yeah.
Even at 130.
Now, go do your frequency, find your relative frequency, and then we'll talk cumulative frequency in just a minute. Cumulative relative frequency. So you start with your first one, which is 0.04, and then each one after it is taking the new category and adding the previous one to it. So 0.04 plus 0.16 is 0.2. So basically what now I'm looking at on the second one is 109 and everything under it. The next one I'm looking at is 114 and everything under it. So 0.2 plus 0.36, which is 0.56. And then the next one,
Oh, 0.82.
math. What am I thinking to make you do mental math? How about the next one?
Oh, we can't use a calculator?
You shouldn't be on this. I will let you have one though, yes, because you're going to be doing more complicated stuff. But come on, guys.
Thank you, Jack.